flexibility matrix. And next we have to generate the assembled element flexibility matrix. Next we have to generate the assembled element flexibility matrix. Assembled element flexibility matrix insists alpha is going to be alpha 1, 0, 0 and alpha 2. Okay, so this alpha 1 is going to be one matrix and alpha 2 is going to be another matrix. So how can we assemble this? 10 by 6 Ci is going to be common, right? So alpha 1 was 2 minus 1 minus 1 2. This was going to be 0 0 0 0. This is going to be 0 0 2 minus 1 0 0 minus 1 2. So this is your assembled element flexibility matrix alpha. Now what is the next step? We have to find out the redundant forces. Remember the equations to find out the redundant forces. Redundant forces F naught. Redundant forces F naught is given by minus, I'm going to write this here, A naught naught inverse into A naught star into F star. Okay, F star is the external forces which we have employed. Okay, now how do you find out A naught naught? Remember the formula A naught naught was, for that we are using the force transformation matrix. It was B naught transpose into alpha into B naught. Remember this? If it is A naught naught, just give it naught to B naught transpose and B naught. Okay. And what is A naught star? How will be A naught star? It will be B naught transpose into alpha into B star. Okay. So these are your two formulas. So now we are going to find out the A naught naught matrix and A naught star matrix. We will find out the A naught naught matrix. So A naught naught matrix is going to be B naught transpose. B naught transpose is, remember the B naught matrix, B matrix is somewhere here. So B naught transpose was, the rows will be becoming column. Okay. So B naught transpose is 1 0 0 0 0 minus 1 1 0. So this is B naught transpose into alpha, right? Alpha is 10 by 6 Ci into 2 minus 1 0 0 minus 1 2 0 0 0 0 2 minus 1 and 0 0 minus 1 2. Okay, so this is your B matrix. And what about the B naught matrix? B naught matrix is same thing here, right? 1 0 0 0 and 0 minus 1 1 0. So you can do this in your calculator if your calculator is going to support 4 by 4 matrix. So I'm directly going to give you the answer. You remember how to multiply this row into this column, right? 1 into 2 plus 0 into 0 plus 0 into 0 plus 0 into 0 is going to give you 2, right? Similarly, this row into this column, 1 into minus 1 plus 0 into 2 plus 0 into 0 plus 0 into 0 is going to give you minus 1, right? So you're going to get a matrix like this. This is going to be A naught naught is going to be 10 by 6 Ci into 2 minus 1 0 0 1 minus 2 2 and minus 1. Okay. So this is your B naught transpose into alpha. B naught transpose into alpha is going to be this. Now you have to multiply this matrix into this matrix. Okay. So you're going to end up with how many rows are here? 2 rows, right? 2 rows and 1 2 3 4. 2 rows and 4 columns. This is 1 2 3 4. 4 rows and 2 columns. So you're going to end up with a 2 by 2 matrix here, right? 2 by 2 matrix. Okay. So your answer for A naught naught is going to be, you have to multiply this with this now. This row into this column. Okay. So A naught naught final answer I am going to give. Please check the answers. A naught naught is going to be 10 by 6 Ci into 2 1 1 4. Okay. So this is your A naught naught. So So, but we need A naught not inverse, right? A naught not inverse in order to find the redundant forces. So, I am gonna find out the A naught not inverse. How do you find out the A naught not inverse? You can either do it with a calculator or you can do it manually. If you are doing it manually, what do you have to do? You have to inverse this. 6ci goes up, 10 goes down. Now what to do? Into 1 by determinant of this matrix into, you have to change these two, A11 and this will be A22, right? This will be interchanged and the signs will be changed here. Okay? So that's how we find out the A naught not inverse. So A naught not inverse is given by, you have to inverse that 6ci goes up and 10 goes down into 1 by determinant of this matrix. How do you find out determinant? 2 into 4 minus 1 into 1. That is 4, 2 into 4 is 8 minus 1 is going to be 7, right? And then what you have to do? You have to inverse these two diagonals. These coordinates is getting inversed and it's going to change the sign. So this is your A naught not inverse. Okay? Now you have to find out the A naught star, right? A naught star was given by the formula B naught transpose alpha into B star. So B naught transpose is again 1 0 0 0 0 minus 1 1 0 into alpha is going to be 10 by 6ci into 2 minus 1 0 0 minus 1 2 0 0 0 0 2 minus 1 0 0 minus 1 2. So this is B naught transpose into alpha. Again you have to multiply with B star. Okay. So this answer you know, right? Which we have already calculated here. This one. This is going to be 10 by 6ci into 2 minus 1 0 0 and 1 minus 2 2 minus 1. Okay, into what we have to do? B star matrix. So remember the B star matrix? B star matrix was 0 0 minus 1 0 and this was 0 0 0 minus 1. So this you have to multiply these two matrices. Okay, these two matrices, this is going to be 2 rows and 4 columns. This is going to be 4 rows and 2 columns, and you're going to end up with the 2 by 2 matrix. Okay, I'm going to directly give you the answer for this. A naught star. A naught star, please check your answers. A naught star is going to be 10 by 6ci into 0 0 minus 2 and 1. So this is your A naught star. So now what we have to do? You have to find out the redundant force F naught. Remember the formula? Minus of A naught not inverse into A naught star into F star is your formula to find out the redundant forces. Okay. So just substitute all these matrices and find out the redundant forces. So if you have a calculator which supports this 4 by 4, it will be easier for you. So minus A naught not, there is a minus, don't forget this minus, and A naught not inverse was 6ci by 10 into 1 by 7 into 4 minus 1 minus 1 2 into A naught star is 10 by 6ci into 0 0 minus 2 1. Okay, and X star. Okay, this is where we are going to make a mistake. X star, we have already given or taken into account the anticlockwise and clockwise moment which we have considered in the S star. Remember in the B star matrix, both the B1 star and B2 star was, we have considered the anticlockwise directions there, right? So please don't take that anticlockwise direction again here. Even though F1 star was minus 150 and F2 star was again minus 150, we are not going to take the directions twice because they have already accounted for this direction when we are constructing the B matrix or the force transformation matrix. It was minus 1, right? So I am only going to take the positive value here. Always do like this. Okay? If you are considering it there, please don't consider it here. Otherwise, if you are not considering it there, please consider it here. Okay? So don't take it twice. So I am going to directly give you the answer. What is going to be the answer? You have to multiply these two matrices first, and then you want to end up with again a 2 by 2 matrix, and that 2 by 2 matrix into this 2 by 1 matrix is going to fetch you again a 2 by 1 matrix, right? The final answer is going to be minus 21.43 and 42.86. Okay. So this is your redundant forces. Remember the redundant forces? We have named it as F30 and F40. So we got the redundant forces.